To pure for vectors. Here you can see we have a long list of objectives in the descriptions. This all comes from the spec. And what I will be doing is going through just a select few exam questions so that you can see exactly the types of questions that you may find. Please remember to like and subscribe. And give the questions a go first before you watch the video to see how it's done, because I may use a different method than you have, but if we have the same answer, that's okay. Okay, so question 1. The line 1 has vector equation and the line 2 has vector equation. Justify given reasons in each case whether the lines are parallel, intersecting or skew. Okay, if they're parallel, their direction vectors will be multiples of each other. Okay, these are direction vectors of the straight lines. They'll be multiples of each other if parallel. So first of all, we have to look at each case. So if parallel, direction vector of line 1, okay, will be a multiple of the direction vector of line 2. Okay, in this case, 6, 3 minus 1 does not equal x lots of 3, 1, 2. This is not true. Therefore, not parallel. Okay? Then, if they intersect, what do we know? Okay, when we intersect them, we'll be able to find the simultaneous equations, we'll be able to find lambda and mu. So if they intersect, 5 plus 6 lambda, because I'm going across the top row, minus 2 plus 3 lambda, minus 2 plus 3 lambda, and 4 minus lambda, this is if intersecting. If intersecting, this will hold true, won't it? 10 plus 3 mu, 5 plus mu, and minus 3 plus 2 mu. Okay, so this will hold true if they intersect. So let's see, I'm going to have, so the second one's probably going to be the easiest one to, it's better to look at the first two. The second one is probably the easiest one to look at. Minus 2 plus 3 lambda equals 5 plus mu. So this means mu equals 3 lambda minus 7. I'm going to substitute that into the first set of equations. The first set of equations is 5 plus 6 lambda equals 10 plus 3 mu. Instead of writing mu, I'm going to write 3 lambda minus 7 because I'm going to substitute that in. So I'm going to get 5 plus 6 lambda equals 10 plus 9 mu minus 21. So then I'm just going to rearrange this quickly. 3 mu, 3 lambda, and then 10 minus 21 is minus 11, 16. So lambda equals 16 over 3. Yeah. Right, then I'm going to substitute this back in to here to find mu. I'm going to get mu equals 16 minus 7, which is 9. Okay, so for the first two, this holds true. So we now see, does this work for the last one? So 4 minus lambda, 16 over 3, should equal minus 3 plus 2 lots of mu, which is 9. Okay, I can tell you now this is not going to equal each other. However, because we have to justify and give reasons, we have to actually work this out. What is 4 minus 16 over 3? 12 over 3 minus 16 over 3 minus 4 over 3. This does not equal 15. Therefore, do not intersect. Therefore, must be skew. Okay, now in the mark scheme, they have, when they solved it using the second and the third simultaneous equation, they got lambda as 2 and 3. However, it did not work for all of them. We have to state they're not equal, they do not intersect, we've put they're not parallel, therefore skew. Okay, this is going to get you 6 marks. Okay? Question 2. Figure 2 shows a sketch of a triangle ABC. So we have the triangle ABC. Given that direction vector AB, so it's saying this direction, to get from A to B, I've gone 2, 3, minus 2. Now remember, this is a direction vector. Okay? Then from A to C, I've gone 5, minus 6, 1. This direction vector, A to C. It says the size of the angle CBA. Oh, no. CAB, but I was thinking in my head CBA. What does it mean? Can't be asked. Giving your answer in degrees to 2 decimals. CAB. So this angle. How do I find this angle?
This formula.
The formula cos theta equals A dot B magnitude of A multiplied by the magnitude of B. I keep saying modular. So we're going to have the dot product is 2, 3, minus 2 times 5, minus 6, 1. It's going to give me 10, minus 18, minus 2. Add them all together is going to give me negative 10. So cos of theta equals negative 10. Okay, the modulus of the direction vector is 2 squared plus 3 squared plus negative 2 squared. All square rooted, 4, 8, 17, so that's root 17, multiplied by 5 squared plus minus 6 squared plus 1 squared, which is going to give me 36, 46, 51, root 52. I can then do cos inverse of that, and I will get, sorry, that's root 62, 107.94 degrees to 2 decimal places. Okay, it then says, using your answer to part B or otherwise, find the shortest distance from A to BC, given your answers to 2 decimal places. So,
We need to do part B first.
oh, we didn't do part B, oh my. Sorry, that was part A, done. Part B, find the area of the triangle. Okay, a half AB, so that's root 17 times root 62. A half AB times sine C. Wait, what? Yep, 107.94, which is going to give us 14.65 to units squared.
15.4.
15.4. Right, we've got, whose calculator are we using? It's 15.4. What have you put into your calculator?
Okay, Nadine.
15.4 units squared. Is it 15.4 to 2 decimal places?
4.
4, sorry. Perfect. Just to say, if you got 14 point something, it's because your calculator's in radians. Please make sure we're in degrees. We were given this in degrees, okay? Right, then next up, part C. Now, I don't know the correct way to do part C, but how I would do it is, if we need to know the height, okay, area of a triangle is base times height divided by 2. So just using common sense here,
Wow.
we have the area of a triangle. What is the area of a triangle? 15.44.
Don't have the base.
We might not have the base. However, if we have 2 directional vectors, we're able to find the length of this, because we've got the magnitude of these two in an angle. We could technically use cosine rule to find the length of this, couldn't we? I mean, there might be a quicker way. Think about this triangle. Forget about it as a vector. Think about it as a triangle. This is 109 degrees. 107.94. We've got, this is root 17. This is root 62. If we need to find this length here, sorry, I don't know what's happened there. We could do that way. So we could use the cosine rule, or I just had a great idea.
Sine rule?
No, we can't. I was going to say if it's an isosceles, we could have halved it. It's not an isosceles. Yeah, so let's find this base here using the cosine rule.
And then we'll be able to work backwards. So what do we know? A squared equals B squared plus C squared minus 2BC cos A, which is 107.94. Okay, who's putting this in their calculator and getting it right for me? Which gives us 99.00, square root that. Root 99 is going to be near enough 10. Okay, so I'm going to keep it as root 99 though. So what do we know? Our base is root 99 times our height. That's what we want to know, the shortest distance from A to B. Okay, divided by 2. This equals our 15.44. So I'm going to rearrange this. 15.44 times 2 divided by root 99 is... So once we rearrange that, our height is 3.1. It wants 2 decimal places, 3.103, so it's 3.10. Okay, just to know, if you have the mark scheme for this question, this method is not on the mark scheme at all. They've given 3 different methods to calculate this part of the question, and the method I used isn't in there. Can you see how vector applies to so many different topics? Or it's literally common sense, okay? This is the same answer as the mark scheme, but common sense. Some of you might have got root 99 by not using cosine. You would have done, and this is also correct, you've done vector BA plus AC to find the direction vector of BC. And then obviously you found the magnitude of that to find the length. That's also going to give you root 99. There's many different ways you could have done this.
Question 3. With respect to a fixed origin, the lines L1 and L2 are given by the equations. Show that L1 and L2 meet and find the position vector of their intersections. So to show that they meet, we know that they intersect, so they equal each other. So for the first one, it's going to be, now I like to write them in column vector form, so 1, 5, 5, plus lambda 2, 1, minus 1. We have 0 to 12, plus mu lots of 3 minus 1, 5. So the simultaneous equation is 1 plus, and then remember lambda, 2 lambda. And we're going to have 5 plus lambda and 5 minus lambda. They're saying this equals 0 plus 3 mu, 2 minus mu, 12 plus 5 mu. So then we're going to have 1 plus 2 mu equals, 2 lambda equals 3 mu. 5 plus lambda equals 2 minus mu. And then 5 minus lambda equals 12 plus 5 mu. Okay, the one I'm going to look at, I will start from the top and see which one's the easiest. This one's probably going to be the easiest to substitute and rearrange. So this is 5 plus lambda minus 2 equals minus mu. So this is going to rearrange to give me mu equals minus lambda minus 3. Okay, I'm going to substitute that into the first one. So I'm going to get 1 plus 2 lambda equals 3 lots of minus lambda minus 3. So I'm going to have 5 lambda equals minus 10. So lambda equals negative 2. So that means mu equals negative 2. Positive 2 minus 3 is negative 1. Okay, let's see if that works in the last equation. So 5 minus 2, does that equal 12 plus 5 lots of negative 1? 7 equals 7. Yes, okay, so I've checked it in all 3 then. So now I've figured out what lambda and mu equals. To find the position vector, I can choose either of these. So if I choose the first one, so R equals, we know it's 1, 5, 5, plus lambda, which we just worked out, was minus 2 lots of 2, 1, minus 1. So let's find position point R. So 1 plus minus 2 times 2 is minus 4 plus 1 is minus 3. 5 plus minus 2 is 3. 5 plus positive 2 is 7. So the position vector of the intersection is minus 3, 3, 7. If you'd have substituted into this one, you would have got the same, because this is how we know. It then says, show that L1 and L2 are perpendicular to each other. So the dot product of their direction vectors will equal 0. Okay, direction vectors is this one and this one. So the dot product of these will equal 0. So let's see if that's true. 2 times 3 plus 1 times minus 1 plus minus 1 times 5. You get 6 minus 1 minus 5 equals 0. Therefore, perpendicular. And then the last part of the question, in the position, the point A with position vector 5, 7, 3 lies on L1. Okay, so this point lies on this line. Okay, the point B is the image of A after reflection in L2. Okay, I am going to have to draw this. It's going to take me a moment, but I'm going to have to draw this. So first of all, to show visualization of what's happening. So, we have our X, Y, Z. Okay, now remember, this is all imaginary. So, 5, 7, 3. It's about here. Okay, because I've gone up, believe it or not. So this is point A. Okay, we then have the line 1, 5, 5 plus, it'd be really good to see where do they cross, minus 3, 3, 7. Okay, so they cross minus 3, 3, 7. Okay, so they cross here. Okay, and that lies on one of the lines. So if they cross here, I'm going to then say, this is not scale at all, but just from my imagination, I'm then going to say that this is L1, because A lies on L1. We know when they cross, they're perpendicular. So I'm just going to imagine, there we go, and this is my right angle, they're perpendicular. Okay, and this is my line, this is my line L2. Okay, it then says, remember this is A, 5, 7, 3. It then says the point B is the image of A after reflection in L2. So this has then been reflected to here, because it's been reflected in this line. So our B is in fact going to be here somewhere. Okay, because it's been reflected in the line L2. So it's been reflected in this line. Okay, so this is good news, really good news. So what we're going to do is, we know the point of intersection is here. Okay, we can call it anything. Point of intersection. I'm going to call it P. Okay, so point of intersection, and we know the point of intersection is minus 3, 3, 7. Okay, so what I'm going to do is I need to find. Okay, so I need to find. Suppose I could find the direction vector, P to A, and then go backwards to go from P to B. Let's see if that works. Okay, so how do I get from A to P? No, let's go P to A and see if I can apply the same. P to A is, how do I get from minus 3 to 5? I add 8. How do I get 3 to 7? 4, 7 to 3, minus 3. Okay, so if that's how I go this way, how do I then go the other way It's like the negative of that, isn't it? So minus 3. So then if I'm going P to B, okay, so remember this is this direction this way. And we know it's a mirror image, so technically this is the same direction vector. If I want to go P to B, I'm going to do this minus this. So here we go. So I'm going to do minus 3 minus 8 is minus 11. I'm going to do 3 minus 4 is minus 1. And then 7 minus 3 is 10. Okay, is that right? No, I've just spotted a mistake, guys. 7 to 3 is minus 4. So this is in fact 11. Guys, always check your maths, just like I do. You know, sometimes I make mistakes. It's completely normal. Okay, perfect. So I get minus 11, minus 1, 11, which is my new point. Now let's just check the mark scheme. Okay, so the mark scheme has done this a different way. They've started from O, the origin, to P, and then they've found A to P, and they've done lots of different adding. However, this logic still stands, still the same answer. This is what I love about vectors, more than one way. Okay, question 4. Relative to a fixed origin I, the points A, B, and C have coordinates respectively. The line passes through the points A and B. Find a vector equation for the line L. Okay, so nice and simple. Equation for the line L, we can use A or B. I'm going to use A. 219 plus lambda, lots of, and then the direction vector A to B. So how do I get from A to B? How do I get from 2 to 5? 3. 1 to 2, 1, 9 to 7, minus 2. Okay? Some of you might do, this is your A, this is your B, C. Some of you, for your direction vector, might do the vector B minus A. That's fine. Whatever works for you. It then says, find in degrees the acute angle between the line and the line AC. Okay, so let's do the line AC as well. So line AC, I'm going to use A again, plus mu of, okay, how do I get from 2 to 4? 2. How do I get from 1 to minus 3? Minus 4. How do I get from 9 to 3? Minus 6. Okay, so how do I find the angle between these two? I have to use the cosine rule. And I know that the cosine rule is cos of the angle equals the dot product of the direction vectors. Okay, now remember these are our two direction vectors. Okay, so I'm just going to call them D1 and D2. And then we need to divide them by the magnitude of the direction vectors. Okay, so dot product. 3 times 2 is 6, minus 4 plus 12. So I'm going to get 18 minus 4, which is 14. Over the magnitude, now we're going to get 3 squared, 10, so root 14, multiplied by 2 squared is 4, 20, plus 36 is 56, so root 56. So then I'm going to put this into my calculator, 14 over root 14, root 56. So I'm going to get cos inverse 14 over root 14, root 56. Okay, and this is going to give me 60 degrees. That was nice and easy. Okay, so just a heads up, make sure your calculator's in degrees and not radians. Right then. Next part. The point D lies on a line L such that angle ACD is 90 degrees. Okay, we now need to start drawing this out. So, I'm going to get this a second. I just need to visualize what's happening because this then tells me the method. I have no idea what method I'm going to use until I've visualized it. Everyone works in different ways. So 2, 1, 9. So this is A. B, 5, 2, 7. C, 4 minus 3, 3. And then it says angle A, C, D. Okay, so we know as well that the line, point D lies on the line L. The line L passes through the points A and B. So my line L is here. This is L1. And then also, part B says find the degrees of acute angle between the line L and the line AC. So if I was to connect AC, I would have AC and the line L. We know this is 60 degrees. D lies on the line and makes an angle of ACD of 90. So this is then 90 degrees and this is D. Okay, so I now need to find the point D. Now, what I technically have here is a right angled triangle. So let me just pull that out a second so that we can see this. We know this is 60 degrees. We need to find this point D. However, we could find it if we had this length. Okay, we do have the length AC. We can figure out the length of AC because we can do the magnitude of AC. Did I do that earlier? I'm not sure, so I'll do it now. This is why, okay, just a tip here. We should write everything down that we're doing. Right, let's find AC, this direction, from A to C. So if we go from 2 to 4, what do we get? 2, 1 to minus 3, minus 4, and then 9 to 3 is minus 6. Okay, so the magnitude of AC is square root 2 squared plus minus 4 squared plus 36 squared, which, not 36 squared, minus 6 squared, which is 36. So 36, 40, 56 I get. So this is root 56. Okay, I have a right angle triangle. I'm just thinking Sokotoa. So, yeah, Sokotoa. Right, now, because I know, so what do I know about this triangle? Okay, I know the length of the line AC is root 46. What else do I know? Just to make sure I've got everything. Root 56 is actually 2 root 14. Okay, where have I seen root 14? Here. What was this? Direction 1. Oh, this is the length of AB as well. So B was roughly here. This is root 14. Okay. But we need to find the rest of the length. So we can do 2 different ways right now. We can find this way or this way. So we're going to go hypotenuse or opposites. Okay, I'm not sure where I'm going with this, so I'm just going to find the lengths of both. So let's find this length first. X. So I'm going to have opposite, adjacent, hypotenuse. If I'm finding the opposite, I'm going to have tan of 60 equals opposite, which is at x, over adjacent, which is root 56. So I'm going to have tan of 60 times 56 equals x. So tan 60 times root 56 equals 2 root 42. So the length is 2 root 42. So from C to D, 2 root 42. I don't really think that gets me anywhere. Okay, let's just try the other one quickly. So if I want to find the hypotenuse and I've got my adjacent, I'm going to use cos. So cos of 60 equals root 56 over hypotenuse. So hypotenuse equals root 56 over cos of 60. And if anyone has an easier way to do this, let me know. So this one's actually, I don't know if I'm making it overcomplicated. It's just really got to me. So we're going to have root 56 divided by cos of 60, which is 4 root 14. There's that root 14 again. Okay, right, here we go. This whole length is 4 root 14, okay? And we know from A to B the length is root 14. So actually, if the whole length is 4 root 14, technically, we could do A to B 3 more times. This is like a ratio. Look at this. I'm going to draw it here. Right, this is A, this is B. It's very clever, actually. I mean, there definitely must be another way. So I know from A to B is root 14. Okay, this is from A to B. So from A to B is root 14. But the whole length, we've just worked out, okay, is 4 root 14. So we could literally, if we wanted to, multiply this. So this is where we're now going to use our equation. So we could do this 2 ways. We could literally just do, so we know, how did we get from A to B using our direction vector? We can multiply that by 4 and add it onto A. This is where the equation of the straight line comes really in handy, because technically what this is saying is R equals A, which is from our equation of straight line. Our lambda here is 4 lots of 3, 1 minus 2. Okay, this is a practical use of this equation here, which is fantastic. Right, so that means that our point R, which is in fact D, equals, so 2 plus 4 times 3, 12 plus 2 is 14, 1 plus 4 is 5, 9 minus 8 is 1. Okay, so our point D is 14, 5, and 1. Right, that's took a lot of my brain power, and I'm not sure if I went about it the right way. Let's see if it's right. Yep, it is correct. Now, the mark scheme way 1 has done something completely different, which I don't really understand. I'd have to sit and look at it. Way 2, very similar to my way, apart from, oh yeah, they've done a ratio thing. Way 3, again, no idea what they've done there. I'll have to look at that. And there's a way 4, so there's 4 different ways of the mark scheme, and this is similar to way 2, which is great. Now that we do that, it says find the exact area of the triangle ABCD. So it's a half base times, because it's a right angle. So remember, this was a right angle triangle. Here, this is right angle. I'm just going to take this out. Well, good job. We worked out that 2 root 42. So 2 root 42. This was root 56. Base times height divided by 2 is just going to be root 56 times root 42, which is going to give me 28 root 3. Units squared. Okay, yeah, you're right. Sorry, this was half times and then 2 here, but I cancelled them. That's why. Perfect. Okay, that took a lot longer. However, I hope that you had, an insight into different people's brains and different ways of doing things. Okay, question 5. Relative to a fixed origin, point A, B, and C, the line passes through the points A and B. Okay, first of all, you know me, I'm getting these column vectors happening. -3, -2, B equals 3, 2, 5, and C equals 2, 4, -3. Perfect. Direction vector A to B. Some people like to do B minus A. I like to say, how do I get from A to B? 2 to 3, 1. -3 to 2, plus 5. -2 to 5, plus 7. Okay, there's a direction vector A to B. And this time, I'm going to label everything. It says, find a vector equation for the line. Well, this is easy. We know R equals A, or you could use B, it doesn't matter, plus lambda lots of the direction vector. Check. Show that the size of the angle CAB is 62.81 degrees. So we know we've got our dot product. the cos of the angle equals the dot product between the direction vectors of the line. So we also need to work out the direction vector of AC, which is, how do I get from A to C? 2 to 2, 0. Minus 3 to 4 is 7. Minus 2 to minus 3 is minus 1. So we need the dot product of AB and AC divided by the magnitude of AB and AC. I have AB dot product AC. So 1 times 0, 5 times 7, 35, minus 7 is 28, divided by 25 plus 49 plus 1, so root 75, and then times by root 50. Funny. Okay, so that's going to be shift cos of 28 divided by root 65 times the square root of 50, which is 62.79 degrees. 62.79 degrees, which is 62.8 degrees, which we've shown. Perfect. Amazing. Then, part D. Hence, find the area of the triangle CAB. Okay, so CAB, if we were to draw this, what is it going to look like? Right, I'm just going to have to get my axes out again. I probably don't need to, but you never know what's going to happen, do you? Y, X, Z. Okay. So 2 minus 3 minus 2, B, 3 to 5, C, 2, 4 minus 3. Okay, brilliant. So we know the direction vector A to B. We know the direction vector A to C, and it wants the angle. There we go. So we found the angle now, hence find the area of the triangle. Okay, so this triangle now, if you think about it, this is A, this is 60, this is B, this is C. We know that AB is root 75. We know that this is root 50. So it's not 60 degrees, it's 68.8 degrees. So half AB, root 75, root 50, times C is 68.8 degrees. Okay, I've just realised that based on my calculator, I got 21,000. Does not sound right. The area of the triangle is not going to be that much when the length's root 75. I forgot to write sine of the angle here, which makes sense. So sometimes these mistakes are easy to make. You've just got to realise that, does it make sense? That's what I'm always thinking. Does this even make sense? It didn't make sense. I realised my mistake. So this is 28.55 units squared. Three significant figures is 25.6 units squared. That sounds more right. Perfect. Now, part E. It says the point D lies on the line L. What was the line L again? The line L is this line that A and B are on. Okay? And it lies on there somewhere. Given that the area of the triangle CAD is twice the area of the triangle CAB. Okay, so imagine if I drew another triangle. Okay, let's just pretend this is D. So this is twice the area. Find the two possible position vectors of point D. So, first of all, let's just do twice the area. 28.6 times 2 is 57.2. So I know a half times root something. Well, we could call it root x, but let's just call that whole thing x, sorry. Because that's my length of AD. A half times something times root 50 times sine of 68.8 equals 57.2. I'm just going to call that x. Okay, so let's rearrange this. So 57.2 times 2 divided by root 50 times sine of 68.8 is 17.35. So x equals 17.3529 ... Okay, not a very nice number, so maybe this isn't going to be the best way to do it. What is root 75? 5 root 3. So root 75 is 5 root 3, which is 8.66. If I times that by 2, I get 17.32, so I have no idea. I have no idea really what's happened there. Because that was, to me, it's like we could double it, couldn't we? Okay, I just realised why I've confused myself. Been a bit silly, really. If my area if this has to be doubled, then the length is no longer root 75, it's 2 root 75. Of course, what an absolute silly billy. One of the lengths is going to have to double. God, right, scrap all this that I've just done. It's just common sense. But hey, if I didn't do what I did, I wouldn't know what I know. So that means if I want to find the position of D, I know that my lambda equals 2, okay? So R equals 2 minus 3 minus 2 plus 2 lots of 157. And at least we've just gone through the logic, because who knows? If I just wrote 2, how would you know? So 2 plus 2 is 4. Minus 3 plus 10, 7. Minus 2 plus 14 is 12. Okay, now it does say the 2 possible positions. Now, if you think about it, this line goes there, but it could also come... Oh, I'm not going to use blue. This line goes up, but it could also, just as easily, have gone the same, but this way, and then this could have been the triangle here, okay? So, instead of plusing 2, if we go in the other direction, we're now going to do the same thing, but we're going to minus, okay? So we're going to have 2 minus 2, 0. Minus 3 minus 10 minus 13 minus 2 minus 14 is minus 16. And there we have it, the 2 coordinates. So let's check the mark scheme and see what method they did. Sorry about that earlier mishap, but it makes way more sense now. So, in the mark scheme, oh wow, they've said there are a number of ways of answering part E. They've done loads of different ways. They've done O to D, and they have put plus or minus 2. However, how did we get our plus or minus 2? We went a long way, but at least we have understanding. So perfect, well done. We have finished some vector A-level questions, and I hope this has answered a lot of your questions and covered the objectives from the spec. Don't forget to like and subscribe. Have a fabulous day.